So now that we have the geometry being baked into Rhino and put on the right layer with the right materials, we need a way to get Rhino to render this view. And we can do this through Python scripting by actually issuing commands to the Rhino command line. And this is another kind of really useful feature of scripting, is that anything you could do by entering commands into Rhino itself, you can do within Grasshopper just by issuing those commands directly to Rhino. And this is actually a really simple process within Python. First I'm going to create another Python node, and this way I'm going to start to break apart some of my functionality into different nodes. But in order to make everything work together, I need a way for this node to know when this one is done. If I just have these as separate nodes, it might start to render before all my geometry is built. So to do this, I'm going to do a kind of a daisy chaining technique, where at the end of this script, once everything is finished and within my conditional, so if it's active and it's finished, I'm going to output a true statement to a new variable. Okay, so here, if it's active and it's done, C is going to take on the value of true, and then else, so if this is false, so if the first node is not active, C is going to become false. So then I'm just going to change this output name to be C, and then I'll inherit the proper boolean. So you see now, while this is false, C is false, and if I set it to true, it bakes my geometry and then sets C to true. If I make it false again, it goes back to false. This is a way that we can start stringing together different pieces of our script to all execute in order. So just like before, I'm going to change the name of my first input to active. And now I'm going to pass in the C output from the first script into the active input in this script. Once I activate this, it's going to go through this whole process, and then once it's done, it's going to output true to C and trigger this one. But if I had put this to false, then nothing will execute. Okay, so I'm going to get into my new Python node, and the first thing I'll do is I'll import the Rhino script syntax again, like always. And like before, I'm going to have this conditional logic, so if active, my code will execute, and then else, and then this node is going to have its own completion output, so C will be true if it's active after everything's executed, otherwise C is false. And this way we can start to chain other things after the rendering, and then we'll just remember to change the output name to C. Okay, so in order to do this rendering, we're just going to start to pass some commands into the Rhino command line. And to do that, we use a function within Rhino script syntax called command. So type in rs.command, and in these parentheses, we're just going to pass exactly what we would type into the command line. So here, as a string within double quotes, I'm going to pass in underscore render. So this will just trigger the rendering within Rhino. I'm going to hit OK. So to test this, we can change this to true. And you can see it's generated my geometry, and only after it's completed, it's triggered V-Ray to start rendering the geometry. So one important thing you'll have to remember to make this work is actually set the options within V-Ray. If you go to the render options, in order to make this sequential rendering work, you need to set, in global switches, you need to set batch render to true. If you don't set this to on, then as soon as V-Ray gets more than one call, it's going to create an error. Okay, so make sure this batch render is turned on before you do these kind of sequential renderings. So now we're rendering each frame, but we also need some way to save each frame to our folder. And that requires just a couple more calls to the command line. So for that, I'm going to pass the save render window command to Rhino. And as an input, that takes in the file name that we want to save it to. So first I'm going to create a couple more text inputs, one with a path to the folder in which I want to save it. So I'm going to create a new folder on my desktop called animation V-Ray. And then I'm going to copy the path to that folder, and I'm going to paste it into this panel. And I'm going to input that name into my script, and I'm going to call it file path. I'm going to create a new input that will keep track of my current frame number. So here I'll change its name to current. And my current frame is being controlled by this animation frame slider, so I'm going to input that into there. Okay, I'm going to use these two inputs to build up the name that I want to save the rendering file as. Okay, so I'm going to go back into my script, and the first thing I need to do is build up the file name that I'm going to use to save my animation. So I'm going to create a variable called saved location equals. I'm going to start with a file path, and then onto it concatenate a string version of the integer of the current frame. So this will make sure that the current frame comes in as an integer, and then it's going to be converted to a string. So this will basically create a file in the path called the current frame, and then onto that I'm going to add .png to save it as a PNG file. And this will already work, but to make it even cleaner, I can use a Python function to actually add padded zeros to the beginning of my number. So instead of outputting as 1, 2, 3, it's going to output as 0, 0, 0, 3 to make sure that once I put this into After Effects, everything comes in the right order. So for that, I'm going to use a Python function called zfill and pass it 4. So this will make sure that all my numbers have 4 places in the name. Okay, so now I have the save location, and I'm going to use that to call another Rhino command. Type in rs command. And here I'll type in underscore dash save render window as, and this dash will suppress the pop-up dialogues within Rhino, so I can actually enter the file name right in the command line. And here n will simulate a space being entered in Rhino, so it's basically has the same effect as typing this command, hitting space, and then I'm going to concatenate that with my saved location string, and I'm going to add another space to that. Okay, so in total this will basically pass this big string, and that string is going to trigger a sequence of commands within Rhino. So in order to kind of figure out what these commands are, you have to play around with Rhino and then basically create a piece of text and see if they have the right function when you enter them into the command line. And then once that file is saved, I'm going to issue another command to basically close the Rhino render window. Okay, so that's all I need for my render script. And now if I set this to true, it's going to generate my geometry. It's going to trigger a V-Ray again, but this time you see that it's closed the window. And if we go back into our command history, you can see we had the render command. Once the rendering was done, we have the command to save the render window. We passed the file name we want to save it as, and then it's closed the render window. If we go back to our folder, you can see that our rendering is here. Okay, so this is almost all set up. Now if we scrub through the animation, we'll actually get different versions of this geometry, and it's going to automatically render this. So the last thing we need to do is actually have a way to delete the geometry at each frame to make sure that more and more geometry doesn't pile up as we keep baking the boxes for each frame. So to do that, we're going to write our last small Python function. We're going to set it up exactly like these two to chain them together and trigger them one after the other. So I'm going to create a new Python node here, change this name to active, and then input the completion output of the rendering script to the active output here. Okay, and this script is going to be really simple. It's basically going to take all the geometry in this layer and it's going to delete it from the Rhino object. So the first thing we'll do is actually create an input into our script, which will tell us the layer that we want to delete from. And you can see now why it's really useful to specify these as inputs, because now I can just drag in the same layer name, and this will ensure that whatever I create, it's going to be deleted from that same layer. And for this script, we again need to import our usual libraries. So we have the Rhino script syntax library, we have the script context library, and we have our Rhino library. And then we say if this is active, the first thing we'll do is change the context of the script to relate to the main Rhino document, because again we're going to be deleting things directly from the document, not from Grasshopper. And then we're going to create a reference to all the objects within a particular layer. So here I'm going to use rs.objects by layer, and here I'm going to pass in the layer input. So what this is going to do is it's going to take the layer name we input here, and it's going to find all the objects on that layer, and it's going to pass a reference to those objects into this variable. Once we have that reference, we can delete all of them with another command called delete objects, and here we'll pass the reference to the objects. And now if we trigger this first function, what's going to happen is basically everything's going to get baked in. Then V-Ray will be triggered, it will render the frame, it will close the window, and then this last script will run and basically delete everything from that layer, so we can start fresh with each animation frame. So now we have our whole kind of generative geometry animation rendering setup complete. And if we go back to our animate function, we can still use the same function, because in effect it will step through every value of this animation frame. It's going to save out the screenshot, but also is going to trigger everything else to happen within Grasshopper, including the rendering of that frame. So we can keep all this as before and hit OK. See, it creates the first one and then triggers V-Ray. It saves the frame, deletes geometry, and then creates the next piece of geometry. And this will happen automatically through every animation frame. If we go to our folder here, you can see all of our frames being created. So you can see that this takes a little bit of effort to set up, but once you get the hang of it, scripting becomes a really powerful tool to basically do things that would either be really hard or impossible to do within Grasshopper Rhino itself.